Hey Algebra 1, happy Tuesday. Today we're going to take a look at how to solve equations with special solutions. Okay, so make sure you have your Springboard book with you, pencil, and your Chromebook. Obviously, if you're watching this on a Chromebook, you got it already. So let's go ahead and get started. So our warm-up for today is solving this equation. Go ahead and pause the video, solve the equation you see on the screen. And if you solve this correctly, your solution should be x equals -11. Okay? So double check your work, make sure you end up with that solution, and let's go ahead and get started for today. So on page 25 in your Springboard book, you should see something like this. You're going to skip over number 1 and you're going to take a look at number 2. But I want to point out some really important parts of the paragraph before number 2. And that is, it says an equation has no solution if there is no value of the variable that will create a true mathematical statement. Okay, so I'm going to have you circle no solution and this little phrase here, true mathematical statement. On the other side of this paragraph, it says an equation has infinitely many solutions if there are an unlimited number of values of the variable that will create a true mathematical statement. So circle infinitely many solutions in that paragraph. And then once again, circle or underline that true mathematical statement. Okay? So basically, we're looking at equations that are true or false, determining if we have no solution or infinitely many solutions. And let's take a look at Laura and Nia and Leo, their equations here. Number 2 says, Laura, Nia, and Leo all solve the following 3 equations as shown. Identify each of the equations as having one solution, no solution, or infinitely many solutions. Justify your responses. So we're going to look at the conclusions for each one of these. And we're going to determine just the way they look if we have one, no, or infinitely many solutions. In Laura's case, she ended up with the solution -11/15 equals x. In this case, because we have x equals a number, this is just one solution. Okay? Just like we saw in the warm-up, we came to the conclusion that x equals -11 is the solution. Laura came to the conclusion that the only value that makes the equation true is -11/15 equals x. Nia, on the other hand, came to the conclusion that 2 is equal to 2 after her 3x's cancel, like so. This means, because we know 2 is equal to 2, that means we end up with infinitely many solutions, which we'll abbreviate like this, IMS. But looking at Leo's solution, 6 equals 17, because we know 6 and 17 are not equal, therefore this is a contradictory statement and also false. That means we have no solution whatsoever for this. It means that whatever value for x that we can think of, we replace x with it, it does not come out to be true. We can also shorthand this by writing a circle with a line through it. Okay? So we're going to go through a couple of examples and determine whether or not they are one solution, infinitely many solutions, or no solution. Okay? And by the way, these are our special solutions. IMS, infinitely many solutions, or no solution. Those are our special solutions. All right? So looking at this example, 3x plus 6 equals 3x, or 3 times x plus 2. Okay? First thing you want to do is you're going to want to go ahead and distribute. So 3 times x, 3 times 2. That leaves me with 3x plus 6 on the right side, and we bring down the left side as it's written, 3x plus 6. Now take a look here. Both of these, both parts of the equation here are the same, exactly the same. Look at them. They have a 3x and a 6. Now they're completely identical. So in order for us to determine what this means, we need to go ahead and subtract 3x from both sides. So we want to treat it as if we're getting all of our x's to one side. So minus 3x, minus 3x. When that happens, 3x's cancel on both sides. I'm left with 6 is equal to 6. Now, just like we saw with Nia, when we have the same number on both sides of the equation, we can conclude that this is an equation that has infinitely many solutions. Okay, so when we get the variables to cancel out completely, that means we end up with infinitely many solutions. So if there comes a point where we're solving and we notice, hey, we've got the same exact thing on both the left side and the right side, we can go ahead and say, I've got infinitely many solutions to this equation. On the other hand, let's say we have the equation 2x plus, or 2 times x plus 1 equals 2x minus 2. And just like in the last equation, I want to go ahead and I want to distribute the 2 to everything inside the parentheses. So 2 times x is 2x, 2 times 1 is 2, and that's equal to 2x minus 2. Now, unlike the last equation, this is not the same on both sides here. Okay, we've got 2x plus 2 and 2x minus 2. So I'm going to still treat this as if it were any other equation where I'm going to solve for a variable. I'm going to bring all my variables to one side by subtracting 2x. So minus 2x minus 2x. 2x's are going to cancel on the left side. 2x's are going to cancel on the left side and the right side. I'm sorry. And I'm going to be left with 2 is equal to negative 2. Now we know that 2 and negative 2 are not the same thing. So therefore, we're going to conclude that we end up with no solution whatsoever. Okay. Once again, we can write it as no solution, or we can write it with the circle and the line through it. Okay. So once again, if we end up with a contradictory statement, we end up not getting a solution for this equation. Moving on with our Check Your Understanding on page 26 in your Springboard book. I'm going to have you guys try out number 3. Go ahead and try this on your own. Pause the video and try number 3 on your own here. All right, take a look at number 3 here. Let's go ahead and see what the solution is, whether it's one solution, no solution, or infinitely many. I have 3 times 2z plus 4 equals 6 times 5z plus 2. When I distribute the 3 on the left side, I get 6z plus 12. And then I distribute the 6 on the right side, I end up with 30z plus 12. Okay? So I'm going to treat this like any other equation. I'm going to go ahead and subtract 6z from both sides so I have as many positives as possible. So subtract 6z, subtract 6z. 6z's cancel on the left side, 30z take away 6z's, it leaves me with 24z plus 12 equals 12 on the left side. Okay. All right, so now I'm going to eliminate the 12 on the right side because I just want z on the right side. So I'm going to subtract 12 here, subtract 12 there as well. 12's cancel, and 12 minus 12 is 0. So 24z. Okay, still have my variable. That means we're going to end up with a solution here. So I'm going to divide by 24 on both sides. That's going to leave me with, move it up here, z equals 0. So this is an example of having just one solution. All right. So a couple other questions in our Springboard book that I want to bring to your attention, and then you'll be able to do your homework. First of all, number 8 on the next page says explain why the equation x plus 3 equals x plus 2 has no solution. Okay? Looking at the equation right here, without even solving it, look at how we have x here and an x here. It's the same x's. Okay? So if I have that on both sides, but I take them away, I'm left with just 3 equals 2, which means they're uneven. There's no value for x that we can replace. We can replace x with that would give us a true statement. Okay, and that's true by just subtracting x from both sides. So therefore, with this being our end solution, that means we're going to have no solution. Okay. And then number 9, for what value of a does the equation 3x plus 5 equals ax plus 5 have infinitely many solutions? Explain your answer. Okay, well, I'm trying to replace a with a number. And if I want infinitely many solutions, just like we saw in the previous problems, I want both sides to be exactly the same. So that means I would want to replace a with 3, which means the equation will look like 3x plus 5 equals 3x plus 5. And that's basically it. That's what we have to do there. Okay? Make sure you're asking me questions if you have any. There will be a link on the HyperDoc for you to ask questions, and who knows, maybe you'll get featured in a little video that I may do with your questions. All right? Your homework is on page 27 in your Springboard books, and you're only doing the odds. Also, please make sure you're going to Delta Math and doing the homework there. Okay? So there is homework on Delta Math for you to try out as well as a practice. Okay, if you have questions, make sure you ask me as soon as possible. I'll see you guys later.